dividing mixed numbers here, right? We're going to look at this in a similar way that we looked at multiplying mixed numbers. So what we're planning on doing with this is we're going to what on earth? We're going to look at dividing mixed numbers here. And we're going to look at this in a similar way as we looked at multiplying mixed numbers. So what we are ultimately going to do is we're going to convert this into a distribution problem. But first of all, we want to kind of understand what we mean by, just refresh our memories on what we mean by multiplying fractions. So when we dividing fractions. When we divide fractions, and this is I really like looking at this in terms of the pizza problem. Okay, so if I have myself a pizza, right? Okay, and I have, well, actually, let's say I have myself half of a pizza, right? So I've got half of a pizza right here. This half here, well, somebody else ate it. Okay, so the rest of the pizza right here, well, we've got there's your cheese. I like a lot of cheese, maybe a bit of pepperoni on top of that, and so on, right? So we've got our pepperoni pizza right here, or half of our pepperoni pizza. So I've got half of a pizza right here, okay? And what I want to do is I want to divide that between two people. So I already have half of a pizza, okay? And I want to divide that between two people. Okay, so I want to divide that here between two people. Well, I can see visually already, well, that's quarter of a pizza right here. And that's the other quarter of the pizza right there. Each person gets a quarter of a pizza. Let's look at how that works out, how that shapes up mathematically. Well, first of all, we know that whenever we've got a whole number that's the same as itself over 1, okay, so we were talking about 1/2 divided by 2 over 1. And let's look at the concept of keep, change, flip. So if we then take this fraction, we keep this fraction, we change the operation, and we flip the second fraction, we take its reciprocal, which is flipping it over, we'll then get 1/2 multiplied by 1/2, because we're flipping this over. And of course, multiply numerator times numerator is 1. Multiply denominator times denominator is 4. So we've got 1/4, and we've got what we expected, right? So this is the kind of the concept that first of all we want to kind of just keep in the back of our minds. Dividing a fraction is the same as multiplying times its reciprocal. So dividing mixed numbers is no different right here. Now, I also want to like break this whole thing up, right? Because what I actually have here is I have a bunch of things going on with this one here. Recognize that a mixed number is really an addition built into it. So I'm going to say that this first one right here, let me color code these a little bit. So this first one right here, 3 1/8, that's the same as 3 plus 1/8. Right, I'm going to put that in parentheses right there. I've got a division going on right here. Okay, so I've got my operator is a division, and then my second one right here, this 1 2/3. I've got 1 plus 2/3. All right, so all I've done here is I've broken all of this up. Okay, now with this one here, it's probably easier to convert these into improper fractions. But I want to take a look at this this way first, seeing as we are dealing with mixed numbers. Okay. So let me deal with this orange side first of all, right? I'm gonna keep what we've got here, but I'm gonna deal with the orange side first of all. So I'm gonna copy everything I've got down onto the next line right here. I'm just gonna say, well, that is equal to and I want to keep this here, 3 plus 1/8. But now I'm going to look at this very slightly differently. I'm going to say, well, I have an equivalent fraction here. 1 I can write as 3 over 3. Okay, 3 over 3 plus 2/3. And I'm just going to change this one into an improper fraction. Okay, so I'm going to keep everything else exactly the way it was. Okay, no changes to anything just yet. 3 plus 1/8. And right now I'm still on the division, and I'm going to just keep it simplified and say, well, this one here is 5, because 3 over 2, you've got the same denominator now. I can go 5 over 3. Okay, so now I have a division problem, and I know, here's the thing, is like I know that I can, I did it only with the second side, because the second side is the one I need to flip. All right, I don't need to worry about the first side. I just need to worry about the second side. So I know from my keep change flip problem over here that that actually does work. So I'm going to apply that in this situation right here. So once again, I'm going to keep my 3 plus 1/8. Right? I'm going to keep all that in there. I'm going to change my operation, and I'm going to take the reciprocal of my second term, which is now 3/5. Okay, now I like to look at it like this, because this now becomes what I like to refer to, well, what it actually is, becomes a distribution problem. So I'm going to rewrite this in the opposite order. I'm going to say, well, that's 3/5. And let me show my parentheses a little bit there. 3/5 times 3 plus 1/8, right? This might look a little bit more familiar to you now, especially as I kind of draw these distribution arcs right in there. Okay, so now all I need to do is multiply this 3/5 times 3 and multiply 3/5 times 1/8. So let's go ahead and do that. So now I have, well, 3/5 times 3, that's 9/5. So I don't mind having improper fractions at this point. 3/5 times 3 is 9/5. So I've got 9/5 right there. Plus, and 3/5 times 1/8, well, numerator times numerator is 3 times 1 is 3. Denominator times denominator, well, 5 times 8 is 40. Okay, I do, however, now need common denominators. Okay, so this is where converting the first one into a mixed number is probably a quicker way of doing it. But I don't mind doing it this way. It's and I can see the denominators. The denominator I need is already 40. I'm not going to need to change this one. It's going to work quite easily for me. So this is going to give me, I need to multiply times 8 above and below. So I've got 72 40ths plus 3 40ths, and that gives me 75 40ths, which then needs to be reduced. So that's not a huge problem to reduce that. The least common multiple looks like it's going to be 5 anyway. So I got 8 right here, dividing by 5, and right here I should have 15 right there. So 15/8. Now it's written in lowest terms, so you're talking about, this is 15/8 is what we're looking at here. You could always, like, you're going to need the 8th anyway. You could have found out how many 40s go into 75, and you'll see that as well. We can see it's 1 and 7/8 is what our mixed number is. 1 and 7/8 right there. But it's that's that for me is kind of one of the easier ways of looking at this. This particular problem is probably one of the more complex ones you'll actually get in it, just because both of the numbers are mixed numbers. But oftentimes you only get one mixed number, so it's simplified, and this is a method that will actually work for you all the time. If in doubt, feel free to convert into mixed numbers first, or into improper fractions first and then keep, change, flip, recognize that you will have to convert back into a mixed number right at the end. You can see Khan Academy right here. Likes a mixed number. It likes an improper fraction as well. So you should be fine either way. 1 7/8. So try that out for yourselves and let me know if you need any help with any of that.